What's up, guys? Welcome to this video on question 7 of the 2017 final exam. It's going to focus on electric circuits. Okay, so let's get into it. A circuit consists of a battery with an EMF of 16.5 volts and an unknown internal resistance, 3 resistors and an ammeter, and a voltmeter, most of which is shown in the diagram. The circuit is connected as shown. Okay, the voltmeter measures a potential difference of 12 volts. Okay, so we start question 7.1.1 with a definition. I know you guys probably hate looking at my handwriting, so I'm just going to say it out loud. But basically, Ohm's law says that the current through a conductor is directly proportional to the potential difference across the conductor at a constant temperature. And from this equation, we get, from this definition rather, we get the equation V is equal to IR, which is our current times our resistance. Okay, and we get 2 marks for a definition. So then the next question says, calculate the current in the 8 ohm resistor. Okay, so we know that this voltage here is 12 volts. That means all the voltages here are equal to, I'm going to label this V1. All of these have got a voltage of V1 across them, including the entire circuit. Okay, so we can look at this as being the voltage across the battery, but because there aren't any resistors here along these blue lines, we can also see this as being drawn over this entire part right there. Okay, and therefore using Ohm's law, we can say that V equals IR. We know the voltage is 12 is equal to our current, which is unknown, and we want it over the 12 ohm resistor, the 8 ohm resistor. So we can carry that calculation out because I is the only unknown, and we get that I is equal to 1.5 amps. So the current here, let's say here, 1.5 amps. Okay, cool stuff. Then it says calculate the effective resistance of the resistors connected in parallel. Okay, so we can say 7.1.3. I don't actually know if this is on the formula sheet. Let's see. Where are we looking? Electric circuits. Yeah, it is. Let's see, 3rd row, 2nd column. We can say that 1 over R parallel is equal to 1 over, let's label this, let's say this is 1, 2, and 3, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R parallel is equal to 1 over 4 plus 1 over 8 plus 1 over 12. Okay, the only unknown here is R parallel, so we can calculate R parallel is equal to, and if we put this in, we get 2.18 ohms. Cool stuff. Okay, this was amps. That looks better. Okay, then we go on to question 7.1.4. Okay, calculate the current measured by the ammeter. Okay, so what I'm going to do now is just draw an equivalent circuit. So the equivalent circuit would look something like this. We have our battery, or batteries, okay, and then what we have is we have our R parallel. Okay, I draw resistors a bit different to these diagrams. I draw them like that. R parallel, which is equal to 2.18, and we know that the voltage was 12 volts. Okay, so now we can use the equation V equals IR. Okay, so we're now looking, I want the current through this entire circuit, so I'm looking for this value right here. So I can look at this circuit, this equivalent circuit that I've drawn. So we know that V is 12 equals I, which is the unknown, times R parallel, which is equal to 2.18, and the only unknown here is our I, so we can solve for I. which is equal to, let's see if we plug that in, we get 5,5 amps. Okay, so this is the current going through here, which is the current going through the entire circuit. So we can put that in as well. This is equal to 5.5 amps, which is very nice. Okay, then it says calculate the internal resistance of the battery. Okay, so how I'm going to do this is I'm going to figure out the voltage loss. Okay, or actually what might be easier is to just look at our formula sheet and look at equation in block, let's see, row 2, column 2, which is EMF equals I. Okay, so that, let's do here, 7.1.5, EMF is equal to I times R external plus R internal. Okay, then we have the EMF was 16.5. Okay, 16.5. I we calculated as 5.5. R external we figured out was 2,18. Yeah, plus R, which is the internal resistance. The only unknown here is R, so we can calculate R is equal to 0.82 units of ohms. Okay, the other way that I like to do it, let's say this was method 1. Method 2 is I look for the voltage loss. Okay, so the voltage that we've lost to the internal resistance is going to be our 16.5 minus 12 volts. Okay, yeah, so 16.5 minus 12 volts gives us 4.5 volts. Okay, so this is our voltage loss. So now and all of that is lost to our small resistor. So V equals IR. The voltage, I'm talking about the loss, and here I'm actually talking about the small resistor. So the internal resistance. So then we have 4.5 is equal to our current, which was 5.5 times R. Okay, then if we look at this equation, the only unknown here is R, and so if we plug that into our calculator, we get exactly the same answer of R is equal to 0.82 ohms. Okay, the reason why I'm showing you this is because sometimes that method might be easier to you, and we get 3 marks for that, which is very nice. Okay, so next we move on to question 7.2. An electric heater which has a resistance of 50 ohms is operated by connecting the power to a potential difference of voltage 220 volts. We start off with a definition, 7.2.1. Okay, this one I'll write out because it's nice and easy. You guys don't mind looking at my ugly handwriting if it's very short. So what is power? Power is the rate of change, or rather rate at which work is done. Another definition, again, because it might be easier to remember that one, power is the rate at which energy is transferred. Okay, both of them will get you your 2 marks. Okay, question 7.2.2, calculate the power output of the heater. Okay, cool stuff. So what have I got? I've got a voltage and a resistance. So let's look at this. I'm looking at the power line, which is the last, last row and the last equation. So if I look at that, I get P equals V squared over R, which is equal to 220 squared over the resistance of 50, which was given in the question. And if we do that, we can calculate the power is equal to, the power becomes equal to 968 watts. Okay, and we get 3 marks for that, which is quite nice considering it was an easy question. Okay, so 7.2.3, electricity costs R1.24 per kilowatt hour. Okay, how long can you operate the heater with 80 Rand? Okay, so we have 80 Rand, so we want to work out the time. Okay, So how are we going to do this? Okay, so we can say that the cost is going to be equal to the number of kilowatts, so kilowatts times our time times our unit cost. Okay, so the number of kilowatts, or our power, in other words, our power was equal to, but we want it in, so power in kilowatts, so that's going to be equal to 0.968 times our time, which is the unknown, times the unit cost is R1.24 per kilowatt hour, is equal to, and we know the cost, our total cost can be 80. Okay, so then our only unknown is T, so our time comes to, T is equal to 66.65 hours. Okay, yeah, and that's that question done, and we get 4 marks for that. Okay, so if we want to know how I got to this equation right here, it's because I did a dimensional analysis. Okay, so dimensional analysis just means that I'm looking at the units. Okay, so the units for power were kilowatts, okay, times, so let's say I've got kilowatts, and the cost, this unit here, is rands per kilowatt hour. Okay, so times the time, which would be in this case we're using time to be in hours. Okay, so this was kilowatt hours, kilowatt hour, so times an hour. Okay, if I did this, what I'm left with is, these cancels, these units cancels, I'm left with cost, which is rand. Okay, so that's how I got to that equation. But of course, it's not on the equation sheet, but if you do enough of these questions, you will be able to remember this equation. So basically, yeah, so I did a dimensional analysis. I have the units, which were given in the question basically. I have the rands per kilowatt. I've got this unit. I know I'm looking for time, so I need that. I've got the kilowatts, and I've got the cost. Okay, cool stuff, guys. That's question 7, and that is 23 marks for us. So not too difficult, a little bit of thinking, but overall not so bad. So thanks for watching, and I hope you guys found this useful.